Now, though, we're taking you to a rocket competition for college students that NASA holds every year. Leading up to this big day is an 8-month commitment that does not count as school credit, just a whole lot of extra work. But as you're about to see, it does come with some other perks.
I'm very sunburned. We've been out here since 5 this morning. Outside of the sunburns, it's been a great day.
Same sunburns, but two very different rocket teams.
We're at the University of Louisville, River City Rocketry. Our team has been a part of this competition for 4 years now. I'm with Tarleton Aeronautical Team in Stephenville, Texas. Not a single one of us have done this yet. This is our first high-powered rocketry competition.
Both are here competing for $25,000 in NASA's MAV contest, or Mars Ascent Vehicle Challenge.
We get to see these young engineers come up with these very unique solutions using very different resources than what we normally would have looked to from a NASA perspective.
NASA has been holding this event for 15 years, but this time there's a twist.
Goodbye.
So in previous years, we are primarily building launch vehicles and recovery systems. This year, they implemented a new system called the Autonomous Ground Support Equipment. This entitled us to load a launch vehicle, and we had to insert a payload into the launch vehicle autonomously, raise the vehicle, and insert an igniter for launch.
This is our ground station. This is what we'll be launching our rocket out of.
Greg's team arrived at the crack of dawn.
I'll get the arm.
So they're attaching the arm to the ground station right now.
Is the servo running? Servo's not running.
Going on. 3, 2, 1.
Louisville is struggling to get their system working before the judges arrive.
We brought the arm back here, and it slammed against our backstop here and broke our 3D printed guide. So we're going to try to 5-minute epoxy it, and hopefully here in the next few minutes we'll be able to test it again.
They're racing the clock now.
Now we're operating our ground support equipment. It's all autonomous, and we're about to run it.
The Texan team is already impressing judges with their robotic prowess.
Out of all the universities competing in, only 4 have completed the task, and these are one team. So they can do the whole process with using part insertion in about 1 minute and 2 seconds.
We had a programming bug in some of our code, and so it was one small portion of the entire ground station that we were trying to fix. So we got here early this morning, kept trying to debug it, and each time that we'd go out to debug it, we had to clear the field once they were about to launch rockets, so we'd run all the way back and try to brainstorm about what the issue was.
They eventually get it going with a manual override. Next step, get the rocket into launch position.
It's to reduce the friction on the rail, just because that's where most power is coming from, so that we can reach our altitude better.
Louisville's having a lot more success with this part of the competition.
That's so much better than having to push it up.
Tarleton State is also ready to go.
8 months of work coming down to right now.
Time to fire off some rockets. The goal, get as close as possible to 3,000 feet, 914 meters. Points are deducted for every foot above or below the mark.
And Tarleton is going in 5, 4, 3, 2, 1, go.
It's actually our second worst launch we've ever had. We shot 100 feet over. Honestly, we wanted to get a lot closer. There comes our payload.
Louisville's turn to launch.
It was the most perfect flight that I've seen from any of our launch vehicles. The launch vehicle left the guide tower at a very safe velocity. It reached 2,280 feet. We had our vortex ring parachute open up exactly as we planned. So we had 3 independent recovery systems all function exactly as planned, and they all landed very safely.
Their parachutes are quite unique.
So this year, we custom designed a vortex ring parachute. So we have 4 independent panels that spin like a helicopter. Assuming there's not too much wind, it's supposed to bring the launch vehicles relatively close to where it's launched at.
In the end, neither team walked away with first prize. That went to the University of North Carolina. But they didn't go home empty-handed either.
We took home the Vehicle Design Award, the Project Review Award, and the Safety Award. We definitely won an award. It was the Maxi Mav second place prize. It's one heck of a ride, I'll say. It definitely is fun. The NASA guys know how to put out a good challenge. It's been a great experience overall.